Aloha, this is Richard Halverson, and this is ITS148. And today we're going to do a project 16.1. So let me share my screen. And we are in chapter 16, developing efficient algorithms. And today I'm going to show you how to do 16.1. All right, so 16.1 looks like this. You're supposed to write a program that prompts the user to enter in a string. And then what it'll do is it'll look at the string and it'll display out the maximum consecutive increasingly ordered substring. And that is the characters, each of the characters is increasing in order, and it's the longest one in the substring, or in the entire string. So for example here, we enter a string, and we enter this string welcome, and it's going to print out the maximum consecutive substring as WEL. Now, this caught me off guard. This W is actually an uppercase W, and then the rest of these characters are lowercase characters. And it turns out that the ordering in ASCII, if we look at an ASCII table, we see that a capital W is the value, the decimal value 87. And then E is 101, and then L is 108, so that's 3 increasing in order. And then after that, we get C, which is down here, that's not increasing. O, that's increasing, so from C to O is increasing, but then M, because it's welcome, M goes back again, so it's decreasing, so that stops that increasing, and then E is even less than M. So the longest string of subsequent characters that are increasing is the W, the capital W, the lowercase e, and the lowercase l. And that's what is displayed out here. It shows as the answer. Okay, so so I'm going to start out now. It turns out that I'll show you something with these projects. Excuse me. I had to sneeze. Okay, so we are in project 16.1, but it turns out that if you look back at the end of the chapter, let's look at chapter 16. We're doing 16.1. If you look back at the exercises in the back of the book, we see that exercise 16.1 is the same as project 16.1. And what's nice about finding your projects back here in the exercise section is that there's a little window here that you can use to debug your program. So in other words, with this thing here, and it's the beginning of every section, you select the exercise that you're working on, and then you enter your code in here, and then you can run this automatic check, and this is the input data, and it'll tell you if you got your program correct. So if we look at 16.1, it's exactly this, maximum consecutive increasingly ordered substring. And so we can use this to debug our code. Turns out that the next one I'm going to do is 16.4, and that turns out it's the same as 16.11. So that the gift wrapping algorithm for finding a convex hull. Anyway, so I'm going to do that later today. Right now, let's work on this one. Okay, so let's see. I'm going to pull up a nice blank sheet of paper here, and I'm going to start by inputting a string. So it's an input string equals, and I'm going to ask the user for an input string, and I'm just going to have a little prompt here. So we're going to enter a string, and then I'm going to I'm going to initialize some variables here. The way I'm going to do it is if we have a string, like let me pop up a whiteboard here. So let's say I have So let's say I have a string y, z, x, a, b, c, a, let's say. I'm going to have a variable that's going to keep track of the beginning of the largest string. So I'm going to call that start of largest. Start of largest. And that's going to, and so as I'm going along, whenever I think I've found another string that's larger than the one I had before, I'm going to set the beginning of that string, the index of that is going to be stored in that variable. And then I'm going to have an end of longest. And that'll be the index of the last character. And I'll make it +1, just be the last character +1, because that's the sort of the convention in Python. And then I'm going to probably separately keep track of the length of longest. And I probably don't have to do that because I can always subtract the end from the beginning, but this is just going to make it easier for me. Okay, so and then I'm going to go. So let's initialize these variables. I'm going to have a start of longest, and I'm just going to set that starting equal to the first index 0. And then I'm going to have an end of longest. And I'm going to make it so the first character of the string is going to be my initial string for the longest string. Okay, it'll be a single character at the beginning. So if that's the case, then the end of the longest is going to be index 1, because I have it 1 greater. And then the length of the longest is going to be equal to 1, because it's just 1 character. Okay, then I'm going to have a I'm going to have an index where I started here, and I keep on going, and each time I go, I'm keeping track of these variables, and this is just going to keep on going until it hits the end. So I'm going to call that start index. So start index, I'll start that equal to 0. And then I'm going to have another index variable that's going to point to the next character to look at. So I'm going to call that current index, and that's the next character I'm looking at. And so the next character I'm going to be looking at is character number 1. Okay, and I'm going to see if the character in index 1 is greater than the character in index 0. And if it is, then I've got 1 longer. Then I know my string is 2 characters long at least. And if the next character I'm looking at is greater than the previous character, then I'm going to keep on going. Okay, so this start index is going to go from the very beginning to the end. So and each time that's going to be incremented by 1. So I'm going to say while the current index, it's not the start index, it's the current index. The current index, while that is less than the length of the input string, so while we're still pointing at a character in the string, the current index is the current character that we're looking at, and we're comparing it with the index just prior to that, with the character at the index just prior to that. As long as character index is not over the end of the index, then we're going to keep on going. And what I'm going to check for is if the current index, if the input string at the current index, which we're starting out as 1. So let's say we're looking at this x, y, a, b, c, d, a, B. Okay, let's say it's that. So the current the start index starts at 0, and the current index is going to start out at 1. So it's going to see if y. Okay, so it's going to say this is different than what my example was, wasn't it? Anyway, it doesn't. So if the current index is less than the length of the string, what's the length of the string? 1, 2, 3, 4, 5, 6, 7, 8. So as long as the current index is less than 8, then check to see what if that character is less than or equal to the one just before it. Let's do it. Put a space here. If less than or equal to the one just before it. -1. Okay, so if this current index, if the character at the current index is greater than, wait a minute now. If it's less than, then we know our current string, the current string is let's see, let me change this to yx. Okay, yx, because that's what it was before. I'll tell you what, I'm going to put spaces in between here just to make it easier to spot. Okay, so if the current index is y, if the current index, which is x, is less than or equal to the input string of the one just before it, then we have to, then we are then we have to reset the index for the beginning of a string, okay? Because we're looking for strings where the second character is greater than the first character, and here we have found a case where the second character, this is the current index, is less than the one before it. So we have to reset our start index. Okay, so I'm going to say the start index is reset equal to the current index. Okay. So what that means is if the current index is x and the current index -1 is y, x is less than y. So that means we're gonna set start index equal to 1. So start index is now going to equal 1, which means it's pointing to x. So x could potentially be the start of a new string. Okay, we won't know yet until we test the one after that. But we know that y is not the start of a new string because x is less than y. So maybe x is the start of a new string. Best case, x is the start of a new string. So that's why we set start index equal to that. Otherwise, okay, if this fails, then that means the only other case is that if that fails, then that means that the current index is greater than the one behind it. So that means that means we're adding 1 onto the length of our string. So what we want to do then is test else if the current length, the length of the current string, which is the current index minus the start index, and it's actually +1 because the current index is going to be the current index is going to be part of the string. So here we're at the case where, let's say the current index is A, is pointing to, let's say the start index is pointing to A, and the current index is pointing to B. Okay, if the start index is pointing to A and the current index is pointing to B, then the length of the string is actually 2. Its current index, which is 3 minus 2 is 1 plus 1 is 2. See, so if the length of this current string that we're finding is increasing, if that's greater than the length of the longest, then we have a new longest. If we have a new longest, then we want to set the start of longest equal to the start index. We want to set the end of longest equal to the current index plus 1. Okay, so this is just so far. We're going to keep on going, and we may find that the next character is bigger than this one, and then we're gonna be doing this again. So each time we should be finding that the current string is longer. It's just going to keep on resetting these values, and so and then the length of longest is equal to the end of longest minus the start of longest. Okay. And then once we've set our new longest, we're going to say that we're going to increment current index. And that's all we have to do. When we're done, we will have this should be the starting of the longest string. This should be the ending of the longest string plus 1. So we can print the longest string is the start. No, it's going to be input string starting at the start of longest all the way to the end of longest. Okay, that now to see that this works, what I'm going to do is I'm going to print out. Let's see. After I've executed this code, I have a new longest. Okay, because this tells me that the string I'm looking at right now is already longer than what my old longest was. And to initialize this, I start my old longest as the first character. It ends at the second character, and the length of it is 1 character. So the first one I come across that's at least 2 characters long is going to overwrite this one, and then from then on, whenever I find a newer string that's longer than what I currently have as the longest, it'll reset this to the new one. So to see that happening, I'm gonna right here I have just set a new longer. So I'm gonna print right here, print longest so far is, and I might as well display out the length of the longest, and then I'm going to print out what this string is. I'm just going to print this out here. And let's see, why don't I start out? I'm going to go ahead and display this thing out right at the very beginning, right when we start out here. Just like that. We have a length of longest and we have a start. Okay. All right. So so let's see what this looks like. I'm going to save this. and bring up a prompt here. And I'm going to go to my desktop. And I'm at this desktop. Test.py is the name of my program. And so I'm going to run this. Py is my Python program, my Python system, test.py. The first thing it does is it asks me to enter a string, and I'm going to enter this string here. How's that? Oh no, oops, better type it in because I don't want the spaces in there. Y, X, A, B, C, D, A, B. Okay. All right. So it started out with Y, and then it wasn't until it found AB that it found a string that was longer than Y. So here it found that AB was longer, and then it found ABC was longer than AB, and then it found that ABCD was longer than AB, and then it was done. It never found a longer one, and at the end it printed out the ABCD. So that's a simple program, and it goes through and it starts by just initializing the longest string as the first character, and then it starts looping from the beginning to the end. It's got a variable called current index, and each time it has to reset. Each time it finds the next character as equal to or smaller than the previous character, then we know that if it was keeping track of a longest string, it just ended. Okay, so once that happens, we're gonna reset our new starting point to what the current index is. If it turns out that the index that this character at the index that we're looking at is bigger than the one just before it, then we have one more character added on to this string that we're keeping track of. And so what we want to do is we want to see if that string that we're keeping track of is longer than our old longest. And that's not going to happen until the current index minus the start index is greater than what the previous stored longest was, and it's actually +1 because the character at the current index is included in the string. It's not one greater than. But we have found a new longest, so we're going to reset this information. Start of longest is going to be what the start index of this current string is that we're processing, and then the end of longest is going to be the current index +1 because we always set the end of longest as one greater, and then we're going to recalculate the length. And then we just increment the current index again, and we keep on going until the current index goes off the end. And at that time, we will have, because each time with a new character, if it ends up being a longer one, we store that information. And so when we're done with the string, current index going all the way to the end of the string, then we know that we have the longest string, starting at start of longest and ending at end of longest -1. All right, so I hope that helps with project 16.1. Thanks for watching.